Welcome to the Pythagorean Theorem Facial Recognition app. This app uses a version of the Pythagorean Theorem to do facial recognition. Here we have 40 different faces. The app contains these 40 different faces along with 10 poses for each face. So for that face, here are the 10 poses. Now we have a total of 400 faces in this app because we had 40 faces, 10 poses each. So if I click on one of these faces, the app will actually go up against 399 of those faces and try to find 10 that are the closest to this particular face, the 10 that it deems to be the closest. Okay, so here's the 10 that it deems to be the closest. This one is the closest, this one is the furthest, so it goes in this order. Now the ones framed in green are good matches. The ones framed in red are mismatches. Now we can go ahead and look at these images a lot closer. So the image I clicked on the previous screen, I want to compare that to this particular image. So here I am in the comparison screen. Now notice these are much lower resolution because that's the resolution that the computer uses. This is the image I just clicked. This is the image I clicked on that previous screen, before the previous screen. And anyway, if I go into Investigate and click on one of these, what I get is the comparison for these two corresponding pixels. This is pixel 171. The value of that pixel there is 30. The value of this pixel here is 100. I get the squared difference between those two pixels. Pixel 171, row 3, column 7. Okay, let's look at another pixel just to get an idea of how this works. Alright, so here I'm at pixel 182. The value for that pixel is 73. That's what that color gray is represented in the computer. 131 is how that color gray is represented in the computer. We've got another square difference value here. Now, we have, this is 23 pixels in this direction, 28 pixels in this direction. 28 times 23 turns out to be 644. That's how many pixels we have in this image. Pixel number 1. Pixel number 644. Now if we take the square differences and add them all up for all 644 of these pixels, we wind up with this value here. Now if we take the square root, the smaller this number, the closer the computer deems these images to be. Now let's go take a look. Where have we seen that before? Well, that's really just the distance between 2 points formula. Now if we have the distance between 2 points formula for in two dimensions, we have 2 coordinates, and that's the formula. Now if we go out to 3 dimensions, well, that's the formula. We're just adding a new coordinate. And if we had such thing as 4 dimensions, that's the formula we would have. So what we are doing, all we're doing is extending this exact same formula out to 644 dimensions, one for each set of pixels. And that's where we're getting this value, and that's why it's based on the Pythagorean theorem, because the distance between 2 points formula is based on the Pythagorean theorem, and the distance between points is actually based on the Pythagorean theorem. So this whole thing is driven by the Pythagorean theorem. Now here we have a little tutorial, so we can go ahead and look, get an idea of what's going on. Here we have a scroll that will scroll through the whole complete set of pixels, one at a time. We can stop it if we want to. And then back to the Investigate so we can look at pixel by pixel. Now let's go back to the original screen. Okay, here we have our 40 faces. Now this is test data that we obtained from the AT&T laboratories in Cambridge. We're allowed to use these images as long as we reference them. But this is only a prototype app. The real app will allow the students to put in their own faces. And that leads to a whole different dimension. It'll be a lot more fun because the students could go ahead and compare their faces to their friends' faces. They could do things. They could make faces, fool around with their faces, make crazy faces to see if they can fool the app or see if they can make their faces look like their friends' faces. Or they could use makeup. And there's all kinds of ways this could be a whole lot of fun. This is a really, really cool way to apply the Pythagorean theorem in a modern context, because using the Pythagorean theorem this way for facial recognition was actually done in a research paper back in the 1990s. So, this is tying technology and the Pythagorean theorem together in a way that's probably have never been seen before in a classroom. Very, very cool.